In this video, we'll be talking about signal routing using chops. So in this first example, I have 3 buttons that are connected to 3 different nulls. And if I click on these buttons, you can see that the null channel populates. So what happens if I want to make sure that all of these channels are multiplied by 10? Well, an easy way that you might think to do this is to add a math to the end of each of these nulls. But that's actually not the most efficient way that we can multiply all of those outputs by 10. Instead, what we might think about doing is merging all of these chops into a single chop by using the merge chop. And the merge chop can take multiple wires from multiple different chops and merge the channels into one chop. Okay, so now when we use a math after this, all of these are now able to be multiplied by 10 using one math operation. In our next example, we have 3 constants, each with a bunch of different channels in them. And these 3 constants I might want to merge into one place, but instead of using merge, I'm going to use another operator called select, which is a little bit more powerful because it enables us to do pattern matching. And pattern matching in TouchDesigner allows us to select from a lot of different things. The first way that we might think about doing this is in the chops parameter here. We could type in our path, constant 1, and then space constant 2, and then space constant 3. But this can be a little cumbersome if you have maybe 50 channels that you're trying to select from. So instead, TouchDesigner gives us the ability to use pattern matching by typing in the first part of the chop's name, followed by an asterisk. And the asterisk will serve as a anything placeholder. Anything can go where that asterisk is, and it will select it for us. It will match that pattern. So now you can see that we have constant 1, constant 2, and constant 3 all being selected from their operators into this one select. So now it looks like, though, that constant 1 isn't really giving us any meaningful data. So I might not even want to pull that for this. There's another form of pattern matching that we can do where we can specify a list of numbers that we'd like to match against. So in this case, I'd only like to match against 2 and 3, so I can go constant square bracket 2-3 square bracket, and this will only pull from constant 2 and constant 3. This is really useful when we're trying to limit the scope of how many different places we're selecting from. The last little bit here that I want to show you is maybe I only care about the banana channels, the channels that are named banana. So in this case, what I might do is go to the channel name, which already has an asterisk, saying anything can be selected there. And I'll say anything that comes before banana, because constant 2 and this colon come before banana, we would say anything before banana and anything after banana I want to select. So now I get the constant 2 banana, and I get constant 2 banana 2 and constant 3 banana 1, and so on and so forth. So that's a really useful way of selecting from multiple places and getting and gathering your data sources in one spot. The next thing that I'd like to show you is the switch operator. So the switch chop, where did you go? Switch chop allows us to take 2 sources and switch between them. So in this case, I have Alice and Bob as my 2 chops that I'm switching between. And now if I move this index parameter between 0 and 1, you can see that I can switch between Alice and Bob as channels. This is really useful in a lot of different contexts because it allows us to route the signal where it needs to go. So for instance, if we use the select that we had before, and we select out of this switch, and then use the channel name to select, okay, I want this switch to look just for the channel name Alice, and this select to look just for the channel name Bob. Now, as I switch back and forth between them, you can see that I'm routing those chops to the correct location, those channels to the correct location. Another thing that can be useful in this type of situation is setting a default. So I'll add an LFO here that I will name the channel Alice. And this LFO will go back and forth here, and this will act as my default. So I'll add one for Bob as well. We'll copy and paste that and move this down here. So now if no data exists in the select, that channel will be the default. And we can set the default by using the replace chop. So the replace chop takes the original channel that we'd like, the original channel information, in this case our default, and the select will act as the replacement if the channel is there. So as I move our switch back and forth, you can see that Bob comes in as that channel as we get information into this select. And we can do the same thing with Alice as well, where we select in Alice as we move. So now as I switch back and forth, you can see that those defaults are being replaced using the replace chop. The last thing that I'd like to look at is the fan in and fan out. So if I were to use the fan chop, I can take a series of channels and fan them in to be only one channel. This is what's called multiplexing. So as I move channel 1 up and down, nothing happens because we're at 0 already. But as I move channel 2, we'll see that that goes up to 1. As I move channel 3, that'll go up to channel 2, and so on and so forth. And the same applies to fanning out. So if I have a channel that can go, between a bunch of different places, we can fan that out into discrete digital signals, which can be very useful in routing. So this was looking at signal routing using chops.